Good morning, pre-algebra. I want to say, first of all, we're getting close here. And also, when you do the assignments for the information from section 9.4 and the next section, when you do assignments 86 and 87, please make sure that you show your work and make sure you do a good job when you take your quiz on it. You're going to actually take those problems, and I'm going to use the exact same problems from those homework assignments. So if you've done a good job on them, then all it's going to be is a matter of finding that problem, double checking to make sure you're right, and putting in the answer. So just please make sure that you do a great job with them. Also, tomorrow, when you work on assignment 86 and you submit it, the final exam, which for you guys is going to count as one test grade because this is your first probably experience with a final exam. The final exam is going to include things that you'll find when you do your submission report. So when you're submitting assignment 86, I've already have it written so that there are some review questions for your final. So you're not going to be getting all of the review all at once. You're going to be getting it in little pieces. So make sure when you do your submission that you have a piece of paper handy to do some calculations and remind yourself of a few things. Okay? And, to take some notes down with that. So it's just a different way of doing things. All right? So let's just jump on this idea of using proportions here. Now, it may not even feel like using proportions. Really, the main thing that we're going to talk about today is a concept called cross products. Okay? And you may or may not have encountered cross products before, but they're a fantastic way of solving proportions and checking to see whether two numbers are proportional or not without having to reduce fractions. So it limits the amount of work that you need to do as far as fractions go. So for example, if I want to see if 4/6 equals 2/3 or not, okay, I want to put in either equals or I want to put in not equals on these. Okay, and because you're good at reducing fractions that they do equal each other. So it's a good one to start with because it's one that we already know the answer to. Okay, we know that whenever you have an equals, or in this case we have a blank and we're trying to figure out if it's equals or not equals, we know that it's okay if you have an equals to multiply both sides of the equation by the same thing. So if I multiplied both sides by 3, and I multiplied both sides by 6, it would give us the same value because you can always do the same thing to both sides of an equals or even a not equals. So what that leads us to is the idea that if I multiplied both sides by 3, okay, the 3's would cancel over here and I'd be left with just a 3 times a 4 over here. And the 6, if I multiplied both sides by 6, and the 6 over here would cancel, but the 6 would stay over here. That leads us to the idea of cross products. What that means is that I can take 3 times 4. Okay, I usually like to go around like this and get 12. And I can take 6 times 2, and it looks like a cross, and that gives me 12. And as long as those two products are equal, that means that the two fractions are equal, or the two fractions are proportional. The two values are proportional. So you're checking to see if it's equals or if it's not equals by multiplying around. Now, drawing with the circles, that's what your book shows, but I'll show you how I usually think of it. Let's check to see if 16/4 and 28 equal each other. Okay, Looks like maybe. So what I want to do cross products. I'm going to multiply 8 times 16. I usually think about it as going around like this. It almost looks like a heart by the time I'm done. So I'm taking 16 times 8. Okay, 48, 128. And I'm seeing if that equals what I get when I do 4 times 20. And 4 times 20, you probably can already tell, is not. 4 times 20 is 80. They are not equal to each other. So what that means, if they're not equal to each other, it tells us that 16/4 is not equal to 28, which you might have already known because you're good at reducing fractions and you know that this one's 4 and this one's not. Cross products even help you when you have numbers that are more difficult. Like, for example, if I wanted to check 4/5 and I want to see if that's equal to 1.2 over 1.5. Wait a minute, hold on, you said never put decimals in a fraction. That's true, but sometimes if you're trying to see if some numbers are proportional, you might end up having some decimals sneak their way in there. And cross products is going to be your much easier way than trying to find a way to make these fractions work out. So I want to take 4 times 1.5 and I want to multiply that out. 1.5 times 4. Okay, 20 and 6. Put the decimal here, so that's a 6. And I want to take 5 times 1.2. So I'm going to move that around this way. 5 times 1.2. And see what I get. 510. And then that's 6 again. Those two numbers are equal to each other, so that tells me that 4/5 does equal 1.2 over 1.5. Notice that I didn't have to work with a single fraction. All I had to do was be able to multiply. And in the multiplying, cross multiplication is an amazing way of solving. I want to bring through a few more that are like this, where we're trying to find out if they're equal or they're not equal. That's all we're doing, finding out equal or not equal by cross products. Then tomorrow when you do your work, you're going to be practicing those concepts. Let's look at a couple more, and then we'll look at a way of solving some problems. Okay, you can even do more complicated ones like 2.1 over 4.9. And we want to see if that equals 6 over 1.4. Okay, so I want to multiply across. Okay, so I'm taking 2.1 over 1 point, or times 1.4. And I can multiply it 4, 8, 1, 2. I know some of you do placeholders here, that works just fine. Move the decimal 1, 2 places. So 2.94. Which actually, if you did a quick estimate, you would find out you're in the ballpark of 2 times 1. So in the ballpark of 2, yeah, that kind of works. And then we're going to multiply across like this. In a quick estimate, we know that we're way off because this is about 5 times 6, so about 30. But let's multiply it out anyway so we can get this whole idea of cross multiplication in your heads very firmly. 9 times 6, 54, 24, 30. I lied, 29. I didn't lie, I just made a mistake. You know, sometimes we make mistakes, all of us. So 29.4. which makes sense because it's slightly less than 5 times 6. These are not equal to each other. Your decimal places, be careful with them. The idea of estimating helps you make sure you're not getting a wrong decimal place. They're not equal to each other, so these two fractions are not equal to each other. And so that's how that works. You cross multiply in order to find out if you've got two fractions that are equal to each other, even if you have decimals involved. What else you can do with cross multiplying is you can solve problems that have decimals or that have variables involved. So for example, if I want to solve the problem x over 6 equals 15 over 18. Once again, we start with one that's pretty easy because a lot of you might be thinking about, well, wait a minute, this is just super easy because I know that this is 6 times 3 and this is 5 times 3. It must be 5/6, then x is 5. Yes, it is. So since we already know ahead of time what the answer is, it's going to be easier to convince you that cross multiplying works. Because if I do this and I make this 18x, and I do this, and I make it 6 times 15, okay, and then I divide both sides by 18, what I find is 90 divided by 18 does equal 5. Okay, yep, it does equal 5. And so my answer is 5. And you say, well, wait, that was more complicated than what I already knew how to do. Granted, yes. But what about when we have something like this? There we go. This one will be slightly harder, because this is in terms of 11ths, and it doesn't become obvious. Now, some of you might pick up on what the answer is without having to do the cross multiplying, but we're going to hit some that are even more complicated. But let's just do this cross multiplying. 4 times 11 is 44. P times 8 is 8p. And then you want to divide both sides by 8. 44 divided by 8 gives you 5. We need to add a 0. 5 decimal point, don't forget the decimal point, 5.5. So P equals 5.5. And like I say, some of you may have figured that out because you're like, this is half, okay, great. Don't lose those skills. But this cross multiplying, it's starting to look a little bit nicer because that was pretty nice, easy work to do. Let's look at another one that might be even a little bit trickier to figure out. Let's do this. Oh, I didn't mean to get that big of a thing. I want this one. Here we go. Let's do 3 over x equals, let's do 8 over 11. Okay, so this one's a little bit more interesting because this one has, these aren't even close to being multiples of each other. So when we do this and we do 3 times 11 gives you 33 equals 8 times x, which is 8x. And I want to divide both sides by 8. Okay, now this is going to be one. It's going to be probably easier to write it as a mixed number. 33/8 is a fraction that can't be reduced, so as an improper fraction, your answer would just be 33/8. So if I wanted to, I could say it equals 33/8, or I could say x equals 8 times 4 is 32, with one remainder, 4 and 1/8. Now that's something that's not quite as likely for somebody to be able to throw out in their head. If you try to do common denominators, that's fine. It just becomes more complicated. So cross multiplication is actually a nice friendly way of doing these type of problems. You can even have a decimal and fraction mix. So if I had like a over 0.5, and that equals 8 over 2.7. Okay, so quite a mix of things here. We can cross multiply, so I can get 2.7a equals 8 times 0.5. Moving this comes around here. This comes around here. 8 times 0.5. 8 times 5 is 40. Move the decimal 1, so it equals 4. I'm going to even leave my 0.0 because I think that'll be easier for you at this point. I need to divide both sides by 2.7. Okay, well, this is an interesting thing. I'm going to take my 4.0, I'm going to divide this by 2.7. I can move my decimal over 1. 27 goes into 40 one time. When we subtract, we get 13. I don't want to bring down zeros. Quite honestly, I would rather make this a mixed number. So I've got down here to the ones place. All I have to do is then put 13/27. Now this is one where your mixed number may not pop out at you. I mean, your improper fraction may not pop out at you. So it might be easier to just put it in mixed number form. So 1 and 13/27 is your actual answer there. Okay, because 13 doesn't go into 27, it doesn't factor, there's nothing to cancel out. So just very, very nice way of doing this problem. So there you have it. You've got your cross products that can help you to solve proportions or solve to find a piece of a proportion. And it turns out to be a very, very nice way of getting yourself an answer without having to deal with as many fractions, except possibly the simplifying at the end. And that's it. I hope that you all have a wonderful and very blessed day.